We talked about recursion and we said that recursive program writing or function writing should be planned differently than how recursion works. When you design a recursive function first time, you don't think about the stack, you don't think about the registers, or you don't think about the call by value, call by reference. All you think is, what is my base case? Okay, how can I handle my base case? After handling the base case, how can I divide the problem into more than one parts? One of the parts is still difficult, but it is not as difficult as the original one. It is a little bit smaller, and the other part is easy to handle. Okay, so this is how you do the recursion. After you do the recursion, maybe you can prove your recursive function using the technique of induction. Okay, so this is how we do the recursion. Let's write a few recursive functions with you. As I said, it is very convenient to write recursive functions on arrays, such as the ones about what? About strings, right? Okay. For example, string compare. How do we do this? Let's remember how we do the string compare. By the way, I had lots of questions about how to compare two strings in the midterm, and people were asking me, how do I know that? How do you know that this z is greater than or equal to ABC? People ask me about this. Of course, my answer was no comment. Okay, so this is how you do the string comparison, right? You compare the first two characters. Okay, if they are the same, then you continue. If this one comes later in the alphabet than this one, then that means what? This string should come later, so this is greater than. Okay, so z is definitely greater than ABC. ABC in dictionary order, ABC should come first, right? So let's write this function then. What am I going to write this? Let me open a new page. I think the attendance is on. Don't forget about the attendance. There should be a way of inserting a page somewhere. Page manipulation maybe, yeah? Yeah, okay. Insert a page right here. Did I insert it? Yeah. Okay, I'm going to write this string compare. So string compare is going to return what? strcmp is going to return an integer. If they are equal, then it's going to be 0. If first is less than the second one, it is like a minus b, right? It's going to be negative, otherwise it's going to be positive. So let's compare these two strings. Okay, constant character s1 and constant character s2. Okay, so first thing, what are we going to do? First thing, in a recursive function, don't think about the stack, don't think about the records, activation records, or anything like that. The first thing when you write a recursive function is to check what? What? Base case, yeah. You think about the base case first. I know how to handle this, okay? I know that if, so tell me the base case.
Null or backslash 0.
If both of them are null or one of them is null.
One of them.
So what are you going to do? That might be a base case, but I think if we choose our base case in a smarter way, maybe we don't have to think about if one of them is null or anything like that.
One of them is different, then return 0. Or
If they are equal, then return 0 is not a good thing, because if they are equal, if the first characters are equal, then I have to continue, right?
I think we check equality and call the function again.
But that's not the base case. What is our base case? When should I return -1? When should I return +1? And when should I return 0?
Different each other.
There are other people other than you and me. Say it louder.
If they are different each other, then it can return.
Yeah, if the first character is different, then I should either return -1 or +1, right? So that's what I'm going to do. Is if S1 whatever the S1 shows is less than whatever the S2 shows, then do you guys remember what this is? This is -1. Is this -1? So I am talking about A and B, right? In this case, I should return a -1. Okay, return -1. Otherwise, if another base case,
S1 greater than S2.
I am watching the guy who's playing with his cell phone. Take your, okay, put them away. So who is saying what?
S1 greater than S2.
Otherwise, if S2 is greater than S2, S1 is greater than, then return +1. Okay, so two base cases. I know how to return a -1. I know how to return a +1. Then, okay, think about it this way. Okay, this is our string and another string. If it is A, B, C, D, E, and this is A, B, C, Z, Z, F, etc. So I didn't hit this case. I didn't handle it yet. I didn't handle it yet. But if I have something like that, okay, D is less than Z, then I am going to return this one. If the other case, I am going to return that one. If they are equal, that means that if A and B are equal, right? I mean, A and A are equal, B and B are equal. So what am I going to do? I need to continue reading the string. So what am I going to do? I will say, well, I mean, if this is the case, right? If this is the case, if this one and this one, and if this is the case, then return strcmp s1 plus 1 comma s2 plus 1. Okay, good. Yes, say it louder.
There are two strings, A, B, C, D, and second one A, B, C.
Yeah.
How it knows where it's going to terminate?
Well, since you are saying that one of them is ABC, the other one is ABCD. Mm-hmm. When I hit this ABC, okay, let's try it. I am not saying that this function is true. Okay, this function is correct. Okay, the other one is ABCD. Which one is smaller? Which one should come first in the dictionary? ABC, right? So how does this work? Okay, this one will skip. This one will call the recursion. This one will call the recursion. This one will call the recursion. When I come here, this one points to \0, right? 0 is less than whatever D is, right? So it's going to return ABC is smaller than, so that's going to be the case. So it will be handled nicely. What else? Yeah?
If the string is same.
Yeah, if two strings are the same, we didn't handle that case, right? I don't see any return zeros in this function. So what am I going to do now? Yeah.
Star S1
equals star S2 and star S1 equals /0. No, correct.
Okay. If both of them are equal to each other, if they are equal and they are 0, right? Okay. So the method, maybe that's a base case. Maybe I should do it at the beginning, right? So I'm going to say if star S1, okay, is equal to 0 and star S2 is equal to 0, then maybe return 0. If both of them are 0, that means what? I am at the end of the string and either this is a null string, both of them, or this recursion brought me to this location. Okay, so recursively done, nicely done. Two base cases, 0 and -1 and 1, because I'm returning an integer, right? I have to return those values from somewhere. So that's what's happening now. Okay, is this a tail recursive function? What was the definition of the tail recursion? The last thing in a function you do is calling that function, okay, and nothing else. The last thing that I do in that function is calling that function and nothing else. The last thing I am doing here, either I am returning a 0, -1, and 1. These are all nice. I am not doing any recursion there, so I ignore the base cases. How about this case? Is the last thing that I am doing in this function calling a function, calling the function itself? Yes?
What about segmentation faults?
What do you mean segmentation faults?
If string ends, we will keep going.
If what?
If a string ends, we will keep going. Let's say.
But it returns 0, right?
Alright, but let's say S2 is 5 chars and S1 is 2 chars. We will go and
That's what we did here. That was the question. Maybe you didn't hear it because he's whispering. He's not talking loud. Okay? So see what you're doing? There is a reason they are sleeping there. Because you are talking too slowly, too whispery. Okay? Good, yeah.
But as the fan said, we continue to increment the \0 pointer to.
How?
Like 2 characters and 5 characters, we hit the.
When you hit this case,
Yeah.
0 is less than ASCII character of D, it will return -1.
But in the first base case, we check if both are the 0. But one of them 0, but the other not.
That's what I am saying here. This one is 0, this one is D. So 0 is less than D, so it's going to return -1.
We have the 0, one of them, but we keep incrementing that 0. We keep going.
How do you keep going? It returns -1. It returns -1, and this one returns whatever it returns, and that one returns whatever it returns. It returns -1. I hit the base case. I am done, right? What you are doing is okay. It is okay, but what you are thinking is in terms of I am calling that, and that one is calling that. No, I handled the base case. Okay, all the base cases are done. Am I dividing my problem into 2 parts? What are my parts? Okay, call this function on these 2 strings. Whatever they return, I am not going to do anything. I will return whatever it is. So the second easy part is very, very easy. In this case, it is trivial, right? So base case, and that. Okay, if you are going to think about verifying that your recursion works, think about, did I handle all the base cases? Previously, somebody said that, okay, we didn't handle 0. Where is 0? So I handled 0, and now I handled -1 and +1. I cannot think anything other than these, and then my recursive case. You cannot write recursive functions without writing recursive functions. Writing recursive functions cannot be learned, okay, by looking at the slides or asking questions. You need to write them, okay? You need to write them. Let's write another one. Pick another one here. String copy. Oh, okay, you didn't answer my question. Is this a tail recursive function?
Yes.
Yes, it is, right? Because I do whatever I do before I calling the function, and I return whatever this strcmp returns. That means what? The compiler may ignore my activation record before I call this string cmp, right? So I don't, when I call a function, okay, all of my activation record can be ignored, can be deallocated, or can be reused immediately. Okay, so that's why this function is as fast as a iterative function. Okay, and it is recursive, but it is as efficient as if the compiler is smart enough, of course, it is as efficient as an iterative function. Let's write another one. So whatever I'm gonna do, I think string what? String strcpy, string copy. Remind me how it works. Destination is the first one, right? So destination is going to be character star d, and source is of course const character star source, and I think it returns a pointer to, what does it return? It returns, string copy returns number of characters it copied. I don't remember. Do you guys remember? It returns the, where is my CPP reference? Let's go there. Well, this is not C++, but anyway, it's going to tell me what. Didn't I do that yet? I guess it works. Yeah. strcpy string copy. Yeah. Okay. C++ reference. It returns same parameters. That's returns a copy of destination. Returns a copy of destination. So it returns a pointer to the destination. Okay. Oh, they changed it a little bit. Restricted. I don't know what that is. Restrict. I don't know what this keyword is. Do you guys know what it is? They added it. They added it in C99. So there are versions of C++ and there are versions of C. Okay. There is no C++ 99, but there is C99. So I don't think that we have this keyword in C++. I don't know what it is. Okay, so it is a character pointer. Whatever it is, maybe I'm not going to return anything. Let's see. Character pointer. Okay, so string copy. What does the string copy do? Let's say if this is my memory and if this is my S source and if this is my destination, I am going to copy these characters one by one, right? That's what I'm going to do until I see \0, and I'm going to copy that one too. And I don't care if I have enough space in destination. I assume that the caller made sure that the destination have enough room. And there is no way that I can check that. There is no way that I can check that. Okay? So what is my base case? It is very easy to it is very easy to handle if the first character of the source is null character, then I copy it and I am done, right? That will be it. So if star source is equal to \0, okay, but I think I need to copy it. I can do assign star S to star D, etc. I can do that, but maybe I can do this at the same time. Let's do this assignment anyways, okay? If, okay, let's assign star D, star S, okay? I did this assignment. If whatever I assigned, okay, is equal to 0, then return. Return, what did it say? It says return a pointer to the destination. But if I return a destination here, let me make this question mark. Maybe let's to keep it easy, a little bit easy, let's make it a void. I just return. Okay. That's it. So I assigned, okay, whatever the source is showing to whatever this D is showing now, okay. So I get this, I copied it to the destination, and I looked at whatever this assignment is giving me. If the assignment is giving me a 0, or to make it just clear, \0, then I just return, I am done. Okay. Otherwise, okay, this is the base case. This is the only base case. There are no other base cases. Then otherwise, since this is a void function, I am not going to say return something, something, something. I am going to do this str what? Maybe I should, this should point to this one, and this one should point to that one. Okay? Then I am going to say strcpy what? You tell me. What?
D plus 1 S plus 1.
Did everybody hear it? Say it louder.
D plus 1, comma S plus 1.
Did you hear it? Okay. D plus 1, S plus 1. Okay. So, that's it. Is that a recursive function?
Yes.
Yes. Right. D plus 1, S plus 1, and that will be it. Okay. If we like to write this, okay, let's make sure that everything works. Do we handle all the base cases? I mean, the only base case is I hit the end of the source string. That's what I am doing. I am assigning a source string character to the destination string character. I am checking if it is 0. Okay. So I am just doing this. I am doing these two things at the same time: assignment and checking it. Okay, at the same time. So if it is 0 and I did the assignment already, if it is not 0 but I did the assignment already, right? I mean, when I call this, I mean, as soon as I skip this if statement, either hit the return part or not hit the return part, this assignment is definitely done, right? This is definitely done. Maybe C people writes it this way. C people, they write it this way, but just to make it a little bit more readable, I am not going to write it this way. Just write it explicitly. We are not, well, exactly C programmers. Let's say I am going to, at the beginning, I am going to do this destination, okay, and S. I will do this. Okay, then if star s is equal to backslash 0, then return, right? Okay, so I am kind of doing this explicit writing. You might say that, how come you are doing this before? How come you are doing this before the base case? I thought the first thing that we should do in a recursive function is the base case, handling the base case. Yeah, that's true, but in this case, I was going to do this statement 2 times. One before the return, one before the string copy, right? So I didn't do that. I am doing this shortcut trick at the beginning. Whatever you do, first do this assignment, then check if you reach the base case. If you did not, then continue doing this. Okay, let's try to implement what the standard CSE is. I should return a, okay, what does it say? Return 0 on success, returns non-zero on error, also on error, writes 0 to destination 0. What is this? Why are there 2 return stuff? Okay, return a copy of the dest. Okay, I am going to return a pointer to the destination. Okay, I am going to return a pointer to the destination, but it looks like, how am I going to do that? I mean, I modify destination all the time. When I return this thing, return D, it will return a pointer to the last character of the destination, right? So that's not going to be good. So how am I going to return a pointer to the destination? Maybe I can write a helper function. Is that possible? Something like that. Okay, something like that. If somebody gives me the destination at the beginning, okay, this is the original destination, character, pointer, OD, okay, this is my original destination, and maybe I should return original destination at the end, and this should be returned, right? Okay, return. But somebody should give me this one. Maybe this should be string copy helper, right? And my string copy should be character pointer. My string copy should be strcpy character pointer D, constant character pointer, constant character pointer as, then you tell me what should I write here. Well, obviously this strcpy will not be a recursive function, but it will call this recursive helper function. What? A single line, just a single line. Return what? strcpy helper D, comma, S, comma, D again, right? Nobody modifies this last one, but it is returned for, it is used for, what kind of return is this? What? How can I make it a return? Oh, if I do this, right? Is it, no. Those 3 characters are, okay, return. Okay. Is this still a tail recursive function? Yeah, it's a tail recursive function. Okay. So let's do another one which might be a little bit more difficult than the others. We did the string copy, we did the string compare, we did strcat. Strcat is not as well, it is not difficult, but we need to think about it a little bit. Okay, let me make this a little bit. What did I do? I think I was trying to do this. Did I do that? No. Make it smaller. Wake him up. Okay, wake yourself up. Okay, what we were doing? Okay, we were doing strcat. Let's remember what strcat does. It's like string copy, but it copies. Okay, let's take this picture again. This is S1, and this is S, and this is D, right? So it says that I am going to find the null character in this D, and I am going to copy these one by one, right? That's what strcat does. Let's make sure if we are putting the parameters in the correct way. strcat is plus assignment operator in, okay. Destination and the source, the same thing. Source and the destination. It's okay. So what does it return? It returns copy of the des. Okay, this is the same thing. The same trick can be used here, but I am going to ignore it. So my strcat will return a void. Okay, so well, in terms of thinking recursively, what is the base case? Base case is this. If both of them are null, S and D, right? What am I going to do? Nothing, right? Is that correct? Yeah, I mean, both of them are null. I handled it. So it's good, right? Let's write it, okay? So I'm not going to do anything. If both of them, oh no, I can't say that because I need to copy this S to D, right? Yeah, okay. So if S is null, then copy it to D, right? Because I need to copy it. Okay. So, and by the way, this picture is wrong, right? Why is this picture is wrong? Why is this picture wrong? Yeah, it should start writing here, right? And whatever this one is, it's going to write it there and it should be \0. Okay. So if the source is \0, the first character that the source is showing is \0, right? Then I'm going to check D. If that one is, if this one is \0, I am going to check if D is \0, then I am done, right? Then I don't need to copy it. That's the, okay, let's write it one by one. Character, pointer, source, okay. Character, or was it the opposite? This is the same thing, right? Was it the, okay, destination and source, it's the same thing. Character, pointer, destination and constant character pointer source. Okay, if source is equal to \0, that means what? I came to the end of this one, okay, and then I am doing this. Let's be careful here. If somebody sends a, okay, if somebody sends a, okay, good, and if destination is, we can come back and we can just correct it later. If this is not okay, 0, then nothing I should do now. I just return. I am done. Right? I am done.
Is it or
And this is and, right?
I will check star D.
What?
I will check star D together with star S.
Because if the star D is not 0, then I might be in trouble, because somebody might be trying to copy a null string to a non-null string, okay, at the end of it, right? Understand? If I'm trying to do this, str cat, okay, a null string to a ABC, right? I want to put this null to the at the end of this one. I should handle this, right? So, sounds weird, but weird things can happen. So this is the first base case. As I said, maybe my other base cases will handle this, but I need to be careful. What other base case I can handle? The other thing is, okay, S is not 0, but this one is 0, right? So it looks like somebody is trying to, I reach at the end of this one, right? \0. S is not 0, S is pointing to the top. D is not pointing to the top, it is pointing here. So let's write this. If star S is equal to, I am not going to keep writing this, okay. If it is 0,
Star D.
okay, and well, if this one is 0, then this one, since I did not return anything, this one must be non-zero, right? Is that correct? Or I am handing the just the opposite, sorry. If D is 0, D is showing to the last character of it, and S is not 0, well, since I did not hit this return case, if D is 0, that means that star S is not 0, right? Okay, so I'm not going to check it. So what should I do?
Assign star S to S.
Say it louder. Assign.
Star S to star D.
Assign star S to star D, then, right? Assign star D, guess the value of star S, then return str cat D plus 1, S plus 1. I handled what case in this case? Okay, I handled, it looks like I am at the end of this D destination and source is not done yet, okay? So I am increasing the destination by 1 and I am increasing the S by 1. But the problem here is this. If I increment D from this position to this position, now I am looking at a place where things look, I mean, I don't know what is going on there, okay? This could be a \0 or not. So maybe before doing that, maybe I should do this. star d plus 1 is 0. So that I put a 0 in here. I modified it. So the next time I'm going to hit this one. By the way, yeah, okay. So that's going to be it. Yeah. Yeah.
Is it in trouble? I mean, we're in trouble actually.
What?
Are we in trouble?
What do you mean?
Because if we are end of the destination,
Well, I mean, what did we say? We assume that destination has enough space, right? That's how the strcat works. If you are calling strcat, like this is my destination, this is my source, you are responsible from the space allocated. D should have enough space to hold both the original D and the S, right? It should have enough space. Okay. Otherwise, yeah, we are in trouble. But both all the C people are in trouble then. Yeah.
Maybe in the first if statement you should say star d plus size of d equals to
Plus what?
plus size of d.
How do you know the size of D?
It's a function maybe we can add.
Well, I mean, then maybe I should call this strcat at the beginning. Okay. Well, you are right, definitely. I mean, I shouldn't write it this way. I should count the number of characters in source, okay, all of them, and start this function from that point. Yeah, you are right. But I am trying to show something here, right? Okay. So I did that. So what am I gonna? What else? What kind of other base cases do I have? If both of them are 0, then I do this. Otherwise, if S is not 0 but D is 0, then I do that. Okay, I do just that. And what else? How about this? If S is not 0, or if D is not 0, what am I going to do? I mean, there are 4 possibilities, right? If both of them are non-zeros, okay, if both of them are zeros here, if D is 0, the other one is not 0 there, okay? If S is 0, D is not 0, what am I going to do? If S is 0, D is not 0, what are we going to do? There is nothing to copy, right? If S is 0, it is end of the string. I don't care what D is anymore, right? So let's handle that one. I think it's going to be okay. If star S is \0, or remember what I said, 0, then return, that's it, void, right? That's the case. And the last case is, okay, if both of them are not 0, what are we going to do now? If both of them are not 0, let me make this a little bit, not done. Okay. Let me make this a little bit smaller so that it fits. Okay, if both of them are not 0, tell me something. Yeah.
strcat get d plus 1 comma s. Just increment.
Okay. strcat. Say it again.
D plus 1
D plus 1
comma s.
comma s. Did you guys get it? strcat D plus 1 comma s. What are we doing? We are incrementing the D by 1 so that we can hit either this case or this case or this case, right? One of the cases. By the way, this is not a base case. I think what we did is wrong here. I think we should do this first. Let's make sure that base cases are handled first. Okay, move it down. Okay, okay, this is that one. And move it here. This is the base case. We should handle it first, right?
Do we need
Then okay. So you understand the logic here? If both of them are not 0, then increment the destination, increment destination by 1, so that I can get to the end of the destination. Then I can start copying afterwards. This is in a way that whatever you were suggesting, right? You said that let's count the number of characters in the destination, and let's increment our destination that much. This is what you are. This is doing whatever you are saying. Yeah.
We don't need first base case.
We don't need the base case. Let's say okay. Yeah, but that's what I said at the beginning, right? Maybe we don't need it. If S is 0, then return, right? We don't have to anything. If F is not 0, but D is 0, right? That's not good now. If S is not 0, but D is 0. If both of them are 0, if S is 0, it just returns, right? Well, it is doing the same thing. Yeah, exactly, yeah. We don't need the first one. Why? Because S source is 0. Why do we need to care about? Yeah, that's true. Yeah, I don't care about the destination. That's true. Let's get rid of this one. Okay. So, base case, if S is 0, then I am done. If D is 0, then do this. This was the trick in there. And str cat. Otherwise, str cat. I was wondering if we can do the same thing at the same time. No, S plus 1 and S, right? Yeah. Okay. I think this turned out to be more compact than your solution. What's your name? Deniz? Okay. This is more compact than Deniz's solution because he said that let's get the length of the destination first. Then after I am getting the length of destination here, right? By calling it over and over again until I hit this case. D is not that thing anymore. Okay. But this is a little bit maybe more less efficient. Why? Because I keep modifying this D plus 1 character. In the other case, I think I didn't have to do that. Okay. Good.
Can I say something?
What?
Yesterday I saw a YouTube video. A man talked about he writes a program about some string comparison and stuff, and it's runtimes take 1 month, and see people make it only 1 second.
Its runtime takes 1 month,
Yeah.
and what takes 1 second?
See people can finish it in 1 second or even half second. They finish it. Same task.
Okay. Well, I mean, those kind of tricks can be played with any language. Yeah, that's true. But I mean, people have been writing this strcat and strcopy since 1974. So it has been like 50 years. For the last 50 years, when they teach recursion or C, okay, they write these functions from the beginning. Okay, it's like, you know the Hittitleri biliyorsunuz değil mi? The tablets that we get from Hittites, they are all tablets. Most of them, 90% of them, are tablets of the students. Students working on tablets and writing something. They are exercising, right? So most of the civilization of that era is from the students. I mean, students doing exercises, etc. So this is what we are doing. Okay, I think I'm not going to write anything more. I think this is the more strcat n or strn copy. strn copy, it counts the number of characters, so you're not going to drop it one by one and etc. So those things are not that difficult. str copy, strn copy, strcat and etc. Okay, they are all fine. The book has the final one. The book has, it says that book, okay, I am going to do this binary search. What's binary search? Binary search is this. If my string is sorted, okay, make a search for a key. Let's say I am looking for 727, okay. One thing would be just linear search, check if this is 27. If it is not, then do the recursion. If it is not, then do the recursion. When I saw 27, then I am done, right? But this is called linear search, and linear search is fine, but it is a little bit inefficient because I know that my array is sorted, right? So why don't I do this? Instead of trying to check every element of it, just check the middle one. It is 10. I know that it is not 27. It is not equal to. I didn't find it, but I know that I don't have to look at this. I don't have to check the first part. So I just ignore the first part. So my problem became half as big, right? So I ignored half the elements, so it's very efficient. Then looking at this array here, half of them, I check the middle. By coincidence, middle is my element that I am looking for. Then I say that I found it. If it is not, let's say if it is 31, I am looking for 31. Okay, so 27 is not my key, so I ignored this part now, right? I ignored this part now. Okay, so every time I read an element in this array, I am getting rid of half the elements of the array. So it is like if I started from 1024, then it is 512, then 128, then 64, 32, 16, and okay, it's like how many times I am going to, in the worst case, how many times I am going to look at the number of elements. It's going to be a logarithm of base 2, and the length of the array is n. If n is 1024, it's going to be 10, right? 10 lookups, that's it. If I am doing the linear search, it's going to be 1000 lookups. That's going to be a lot expensive. That's why we like these kind of algorithms. They are very efficient. But the thing is that, well, I can do this recursively. Why? Because, I mean, what is my base case? Base case is just check the middle element in the array using the indexing. If it is there, then I found it. Return true. Okay, I found it. If it is not, I am going to do the recursion. When I do the recursion, I am going to ignore this part or this part. Okay, but the problem is exactly the same problem, only my array has changed a little bit. So let's look at the book's implementation. If I can find it, it is here, right? Say that search, get the array, okay? Get the first and last element that I'm going to check inside the array. So at the beginning it's going to be, first is 0, last is going to be the number of elements inside the array. And this is my key, I am the one that I am looking at. And this is found and location. I mean, I don't like this. I am going to change this. Okay, my function is going to return an integer. Okay, if this integer is a negative one, it means that I couldn't find it. Okay, if it is positive, it is the position of the element that I am looking at. Okay, so the first thing is base case. If first is greater than last, if somebody is saying that, okay, I'm going to give you an array, you are going to look at this, okay, look for this key. Your starting position is 5 and your ending position is 4. 5 is greater than 4. What am I going to do? I mean, I can't do that. So I am going to return -1. I couldn't find it. Okay? I couldn't find it. Otherwise, if first is not done last, okay, get the mid element, first plus last over 2. If key is equal to a mid, okay, then what? Return what? Return, yeah, the found position. Okay. If Okay, the two base cases. One base case is the case that I found it. The other one is the case I didn't find it. Well, if I didn't find it, okay, like that one, and if I found it, I handled it. For the other cases, if key is less than a mid, that means what? My key is less than the middle element, so I am going to do this recursion. Return the same function a from the first element to the mid minus 1, look for the key. Okay? And if not the case, actually they didn't need this as part like that, that's enough. Or I don't need this as part, right? And I will say return a mid plus 1 and last, and that will be it. Okay, nice.
And also, you don't need to allocate needs.
What?
You don't need to allocate a need variable in stack.
I don't need the other case. You mean this case? Why not? If I don't do that, then I wouldn't recurse on the second part. After this return, well, it is returned. I'm not coming back. If this did not happen, then this should happen. By the way, I hate these curly braces because I don't need them. If you don't need them, my C style says that don't write them, right? They don't make it readable, they make it unreadable. Shorter looking functions are better. Okay, while you read it, I am dealing with my what? Okay. So, of course, this is a very bad indentation, yeah. Good. Is this a tail recursive function?
No,
Why not?
just allocating need.
What?
Allocates need.
It allocates what?
Need variable.
No. I mean, allocating something local doesn't mean that. Well, what is the definition of the tail recursive functions? What's the definition of it?
It doesn't overflow stack, right?
No. You are making things up. What is the definition of the tail recursive functions? In a tail recursive function, yeah?
The recursion call, we don't make any calculation.
Yeah, the last thing that you do in a function is a recursive call, yeah? So this is the last thing in the search. Last thing in the search, okay? That's it.
Okay, can I ask you something?
Yeah.
Can this be overflow stack?
Can this be what?
Overflow stack.
Stack overflow. Stack overflow. No, it can't. I mean, if it is compiled right, this will not use any more stack space than a regular iterative search function.
I'm asking because it's stored every step needs.
No, it doesn't have to. Why? Because when you call this search function, okay, when you call this search function, you don't need this mid anymore because you did whatever you did with the mid already, okay? You are done with mid or first or last.
Deallocates.
Yeah, well, it doesn't deallocate it, but it reuses it. It reuses it for the new called function.
Uses the same.
Yeah, same memory allocation. So it doesn't have deallocate and allocate. It is not that inefficient. It reuses that location. So if I compile this in a smart way, let's go to our CPP and compiler explorer. Let's see if I can see it. By the way, I am way out of time, but that's okay. Okay, so let me get rid of this one. Yeah, so let's see this line 12. What does line 12 do? Does it call this? Where is my, okay? The first search is, okay, this one, where is it? This one, search is the name of the function. Let me make this a little bit larger so that everybody can see it. Okay, so this one is for the function search, right? Do I see anybody making a call like this one, search, here? Okay, where is it? This one, where is it? Line 12. Let's go to... Yeah. Yeah, it makes a search. It makes a call. See, it makes a function call. But if I optimize it, oh, okay, the number of lines of assembly code just became 24 lines, and you don't see any function calls, right? It just loops. So when I line 13, see, line 13 is jumping to L8. L8 is here. So it's jumping to the beginning of the function. It's not making a function call. So this is not an, I mean, for us it's a recursive function, but for the compiler, I optimized it, it's an iterative function. It is as fast as other functions. By the way, don't tell Yakup Hoca next year when you take the programming languages, okay, don't tell him that I told you about the tail recursive functions. He doesn't like it. He said that I should be the one first talking about it because I am making you confused. And I mean, I tell him that they are confused anyways. I mean, you can't help it. But don't tell him, okay? Okay, good. People say that, okay, after your second year, okay, you are good enough to work at a professional software engineering job in Turkey using your knowledge of your second year classes. That doesn't mean that you are an engineer, right? People say that you don't have to take the programming languages or the operating systems or the algorithm classes because you don't use them. Well, that doesn't mean that you shouldn't know about them because your work doesn't use it. I mean, except that in Turkey, most of the professional software engineering jobs are not. They don't need to hire computer engineers for those positions. Okay, 2 years of or 1.5 years of 1.5 years of good education is enough for those kind of positions. But I mean, Turkey is not the only place in this world to work as a software engineer, right? I mean, the fact that we are not using any software engineering principles or computer engineering knowledge in our software industry doesn't mean that you shouldn't learn them. Okay, if you work at a place where your 2 years of knowledge is enough to work there, that means that you are missing something, right? You should look for somewhere else. You should try to think about making your career a little bit better. So if you saw that you're not using any knowledge from your 3rd or 4th year, then you are at the wrong place. Maybe you are not working as a computer engineer or software engineer. Okay, so that's what Yakup Hoca says. Okay, I mean, he talks about why these kind of decisions are made. I mean, programming language decisions, why this language has this one and this language doesn't have it. Or when you take the operating system course, you are going to see the structure of the real process. I mean, how the operating system is interacting with your programs. Once you know that, then you can be a good software engineer or computer engineer. So that's kind of what we are complaining about in this department. People are not paying attention to our 3rd year and the 4th year classes, but those are the ones that make you computer engineers, okay? The first 2 years are just preparation classes, okay? Everybody can learn them. Only engineers, good engineers, knows about the 3rd year and the 4th year classes, okay? So be careful about those, okay? Listen to, okay, you have to listen to me anyways, because if you don't know C or C++, you're not going to be hired at any place anyway, okay? But if you want to be a good engineer, then the 3rd year and the 4th year classes are important. Okay, let's take 10 minutes of break. Let's be here at around 9:50. Bulaşık makinesi. Bulaşık makinesi.
Başka bir
Yarın 22'si değil mi? Sonbahar elimizde mi var? Başka bir yer. Evet, şu an bulunuyor kanka. Ondan kalacak.
şey olacak. Bak şunlarla yakın fotoğraflar da kötü geliyor.
Discreet ama ne?
Bakar mısın?
baştan sona. Ağırda takıldı. Ağırda takıldı. Bir
Varsa daha fazla.
ona maksimum ben tekrar bana bakarsın.
Ona göre de
Ama şimdi hani ikimiz aynı konuşuyoruz. Kimin konuşacağımız kaldı.
Ona 100 buradan elektriğin oraya varmaz bile. Bizim bu bina kadar falan da.
olabilir. Yok.
Bak burası kaça kaçtır? 10 olmaz mı?
O da mı?
15 falan vardır.
O da mı?
Ha bura.
Tamam değil ya.
15 Şurası 10'a da 4. Bilmez.
7'yi yetiriyor.
Ne yedi yedi?
7'yi yetiriyor.
Aynen.
Ona yetiriyor.
Ne yedisi? Evler bile çocukları.
Ona değil o yüzden.
Ne elisi? Sen sürünüyorsun kanka. Sana bir adamı bir metreye
Değil, metre değil.
Yine susuyor. Oğlum nereye su var? Kedi sana. Ondan su var.
bakmama başladı. Şu diski de salalım. Bu hafta sana bir bonuslar bakalım. Haftası bonuslar bitmeniz yok. Ama ben tek başıma dur bakayım. 150 çarpı 8 kaç yapıyor? 2 15 saatte bitiririm tek başıma. Şimdi 4 kişi girersek 8 saate falan. Her gün 10 saat basın merak ettim başlamayın. Bankada hiçbir yok.
Lodos mu bu arkadaşlar? Sen Lodos mu? Ne taraf güney?
Baba sakallı. Bak oğlum.
Dışarısı 25 derece. Okay, so recursion is nice. The bad thing about recursion is the stack overflow. But if you do it right, okay, with the tail recursion, you will get best of the both worlds. By the way, the book, after this one, I think it gives us the iterative version of it too. Let me try to open it. The iterative version is this one. it just does the iteration, yeah, in a while loop, right? In a while loop, and when I look at this one, let me copy and paste it in this place here. Compile, 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 and this is the search. Okay, the first search, Z6 search. Okay, you know what this is, right? PK, I's are all integers. What is P? I think a pointer, constant pointer I integer. Okay, then 1, 2, 3, 4, 5. 1, 2, 3, 4 integers later. Okay, and this is search, another search. As you see, total number of lines is 55. And yeah, the first 24 lines is the recursive search one. The last 30 lines is the non-recursive ones. So of course it is not correct to compare these two functions by looking at the number of lines it produced, but it tells you something. Both of them are not recursive, and I don't think that one of them can be any more efficient than the other. So, I mean, recursion doesn't always mean it is less efficient. Okay, good. So let's go back and let's wrap up this chapter. Recursion is nice, and with the recursion, we can write some very complicated functions in a very, very small number of lines of code. And binary search is one example here. And what else can I say? Yeah, as I said, with the arrays, recursion arrays or graphs or trees and that kind of stuff, repeating stuff, recursion fits very nicely. That's why you are going to write lots of recursive functions next semester in your data structures course. Okay, that's it about recursion, chapter number 13. I am going to start chapter number 14, which is about inheritance and polymorphism. Are there any questions? Okay. If there are no questions, let me start talking about chapter 14. Chapter 14. Yeah, here it is. Okay. Okay. So, remember what we said at the beginning of the semester? We said that encapsulation and abstraction are two of the principles of object-oriented programming, okay? Encapsulation and abstraction. Encapsulation is put together all of your data and define your functions on it and put it in a capsule, and this is what you call encapsulation, and abstract away any details of what you are doing inside your class. Abstraction. Okay, abstraction is not done only one way. There are procedural abstraction, data abstraction, there are other types of it. For example, function calls are procedural abstraction, right? I don't know how sine function works or cosine function works. I just call them just procedural abstraction, okay? Or recursion does the same thing. Remember, we don't talk about activation records or call stack or local variables and that kind of stuff with the recursion. We say that base case and the recursive case, and that's it. That's called the abstraction, procedural abstraction. And there are many ways of achieving this abstraction, and we are going to see this many times in this course or next semester or your third year or rest of your life. So among all the principles of object-oriented programming language, okay, encapsulation, inheritance, whatever, abstraction is the one that you are going to see the most often. Because you don't need object-oriented programming to do the abstraction. Abstraction is something that our brain works, right? Our brain works by abstracting away details of stuff. Okay, good. Let me introduce two more fundamentals of object-oriented programming, fundamentals other than the encapsulation and abstraction. One of them is inheritance, the other one is polymorphism. let's don't make these complicated names confuse you or make you scared. Okay, they are very easy actually. Let's look at the inheritance first. Okay, inheritance is all about code reuse. Okay, code reuse is something that we like in software engineering. Why do we like code reuse? Can somebody tell me why we like code reuse? We like to use the code written before a lot. Why? Because we don't have to rewrite it. That's one thing. The other thing is what?
Probably tested.
What?
It probably tested.
It was tested, right? Testing is something that we do a lot, that we should do a lot, and it takes up lots of time. It is not fun, and it is not a trivial thing. You might think that designing software, implementing it, okay, is the difficult part of development, software development. No, the difficult part is the testing, okay? Difficult part is the testing. Already debugged, tested software is something that you don't want to waste, okay? If it is written before, then I like to use it again. So code reuse is something that we like to do a lot, and inheritance is a tool that applies this code reuse principle. The other thing, remember composition. Remember composition. Use an instance of another class in your class. Okay, code reuse. Using string in your, for example, person class. Using day of year in your holiday class. Using a vector in your Tetris class, right? These are all examples of code reuse, and I trust that string works, and I trust that vector works because the both of them are more than 30 years old, right? They have been tested a lot. Their performance is acceptable, and etc. So we are going to apply the same principle with the inheritance, and you are going to see that it's a very intuitive way of achieving this code reuse. And you might say that, well, this is very easy, and what is the big fuss about it? Well, it is not that difficult to understand and apply, but it's a big principle of object-oriented programming. Polymorphism is only done through inheritance. So let's first learn about inheritance. For that, I am going to show you some, let me close these so that they don't get in the way. No. I have a class named employee. Okay. This one is nicely in a namespace Savage employee. Remember, Savage is the last name of the book's author. Okay, Savage employee. It says class employee, semicolon is here. Employee is çalışan, right? Employee is, it keeps the name of the employee, the social security number, TC kimlik numarası in Turkey, right? And net pay, how much I am paying to that person. I don't know if it is weekly or monthly or hourly, I don't know. That's not that clear actually. This, how much I should pay to this employee is not clear because I don't know what kind of employee is this, but this is a class like that, okay? So I have getters, get name, get social security number, get net pay, set name, set social security, set net pay, and print check. Print check is something, okay, it's like the bordro, Türkçe bordro, bordro verirsiniz ya ayın sonunda adamın eline. This is like the check, okay, this is your check, you are going to go to bank with it and you are going to cash it, okay? So I should print a check for the employee at the end of the week or at the end of the month, or I don't know, I mean, depends on the employee's type, and in this case, I don't know the employee type. So very simple class. Implementation-wise, let's see the implementation. Constructor just says that, okay, for an employee, no parameter employee, no name yet, no number yet, and why can't I do this scrolling? Okay, net pay is 0. I don't like this kind of initialization. I mean, why do you set the name to no name yet? How about if I have a person whose name is no name yet, that will confuse me a lot, right? So, I mean, this is not a good way to initialize your uninitialized employee. Maybe I should not have no parameter employee constructors, because if you are constructing an employee, it should have a valid name, right? Anyway, so this is a mistake, but I'm going to continue with this. The second constructor takes the name and the social security number, and I am going to set it to this one and this one. Net pay is 0. Getters, setters, net pay, and print check, it says that, okay, I'm going to exit 1. I don't know what to print, okay, because I don't know the employee type and etc. You might say that, why don't you set it, but there might be many different types of employees. And in fact, let me show you what kind of employees I am going to have. I am going to have, for example, a salaried employee. Salaried employee is this. It is exactly the same as the employee. It has the name, it has the social security number, it has the salary. Salary is how much I pay to that guy weekly. So that guy works for a week and I give him that much money. Okay? So for this employee, the net pay is the same as salary. Okay? And rest of them is same as the employee class. I have the getters for the name and the social security number, setters for the name, social security number, pay, print check. I think these two are new, right? Other than that, let's try to compare this one. Okay, it is very similar to employee.h, only I added one new data member, and I have added related to that data member, I added two getters and setter. I added one getter and one setter for that salary, right? And implementation-wise, everything is same as the employee, but get salary and set salary is new. And print check is now meaningful now, okay? I say that pay to the order of this person, sum of net pay, and etc. Because I know how much it makes, and it makes sense now for the salaried employee to make a print check. So the rest of them is same as the employee CPP. All I am going to do is, get all of them, copy them, right? Copy them and paste them into this location, and with Control H doesn't work, search and replace, replace all the employees with salaried employee, right? Maybe I didn't write it correctly. Replace all of them. How many replacements does it make? I am not going to do, well, I'm going to replace it anyway. Okay. So I replaced all of them, and I think I made some mistakes, but this is what happens when you copy and paste stuff, right? So this is how we do it, right? I mean, the class employee is very similar to, salaried employee is very similar to class employee. I copy pasted the code and I modified it a little bit. And some of them maybe I shouldn't modify them. I should do it by hand, etc. I compile them, and I am happy, right? So is what I'm doing right? Do you see something wrong with what I am doing with this copy and pasting? What was our rule for the C codes? Copying and pasting and modifying is bad, right? Why is it bad? Code duplication is bad. That's called code duplication. If you have duplicated code, what's the problem with code duplication?
You can abstract the way.
What do you mean the abstracting away is the problem? What is the problem with code duplication?
I'm saying we can.
I am not asking for the solution. I am asking for the problem. What is the problem with code duplication? Why code duplication is bad? Yes.
When we change something, we have to change other location.
Why do you change something?
As maybe we want to set salary changeable.
Maybe you realize that you made a mistake.
Yes.
Yeah, so you are accept that you are a human being. Okay, so, everybody, I mean, we are human beings and we make mistakes. After copying and pasting, okay, after doing all those modifications, I realized that I made a mistake in employee, right? So what am I going to do? I am going to change that in employee. So what is the big problem? I am going to change the same thing in salary the employee too. But how about this one? If I have other types of employees, such as hourly employee is something that you is an employee that you pay him or her by the hour. If she works 40 hours a week, for each hour I pay them, like, let's say 100 liras, okay? It's like 100 times 40. That's how much you should pay them. So it's an employee, but it's an hourly employee. It's a little bit different than a salaried employee. There might be other employees, for example, commission employee. I pay them by the commission. Okay, if you make a sale, let's say I sold goods for maybe 1 million liras, right? I am going to pay you 2% commission out of those 1 million Turkish liras. So that's how much you are going to get. So another type of employee. If I keep doing this, copying and pasting to this salaried employee, hourly employee, or commission employee, and if I realize that there is a problem with the employee class, then that will be a problem. That will be a problem. So how are we going to solve this problem? How are we going to solve this problem? Maybe I can do this. Instead of copying and pasting, okay, maybe I can do, let me go back all the way. Okay, let me go to salaried employee. This is what I am going to do. Okay. Employee E. Okay. Inside an salaried employee, okay, I keep employee. Okay, E. So when I do this salaried employee constructor, for example, where is my, get salary, okay, for this one, let me write this salaried employee constructor. Salaried employee constructor, control, okay, and okay, this one, salaried employee and salaried employee constructor. Let's do the no parameter constructor first. Okay, so remember how we do that? We have just two things right in it, salary and E, right? How am I going to do that then? I can say, let me write it the explicit way. This way, this way. Okay, I found it. Okay, so with the salary employee, I think the salary set salary 0. Okay, then E dot set name to this one, right? And E dot set SS and to again this one. And what else do I have inside the E dot set pay? I think that was it, 0. Okay, so I reused employee.h. Okay, I included it and I'm using it. And if I realize there is a problem with the employee, I fix that problem and my salaried employee is automatically fixed, right? So how am I going to write this? Salaried employee, for example, get name, right? So it's a const thing. Why doesn't this work? Okay, it worked now. So what am I going to do? I think it should return a string, right? So what should I do? Tell me. Return
E.getName.
Okay. I am glad you learned how to speak after half of the semester gone. What's your name? Turul. Okay. So e.getName, that's it. Okay. Set name is going to work that way too. Okay, let's write the set name. Salaried employee set name and const string name and set name. Okay, it doesn't return anything. Void. Good. So I am using the whole employee class to implement this salaried employees. What did I do? I used the principle of composition, right? Composition is a nice example of code reuse. But still, I mean, there is something wrong with what I am doing. The thing is that I have to repeat all of the functions of the employee class one by one, get name, set name. I have to pass all of them to this get name, set name, and etc. All of the parameters, etc. I have to do all of that stuff, okay, one by one. I can make mistake while writing this stuff. Still, I mean, if I find something not right in the implementation of the employee class, as soon as I fix it, this one is fixed, right? Because I included this employee as a data member in my salaried employee. That's nice. That's a good example of software reuse. But I feel that it is not good enough because when I am writing all of this implementation stuff, I have to repeat all the get name, set name, and etc. C++ or any object-oriented programming language says that for these kind of cases, you can do this inheritance. Inheritance is this. Inheritance is this. Okay. You can define this relationship. By the way, these are, did I talk about any UML diagrams to you guys? UML diagrams? I guess I did not. Let me talk about the UML diagrams a little bit. UML diagrams are this. Page manipulation, insert, and yeah. Okay. In any object-oriented programming language, okay, we represent, okay, our classes, these are called class diagrams, which are simple squares or rectangles. We say that this is my employee, okay. We divide this employee into two, okay, data members and the function members, okay. Let me put my data members here. Minus means it is private. Name. I have a private data member. It is strings, name is name. And SSN, another string. Okay, what else? I think it is pay. Pay is maybe a double. These are my data members, and they are all private. And for the function part, I have this plus means public. I have the employee constructor. I have the other constructor, but I'm not going to write it. I have this set name. Okay, it takes these parameters and etc. You put all of your functions in the upper part. You put your data members in the lower part. For the public ones, you put a plus sign. For the private ones, you put a minus part. So instead of writing the whole class in C++ code, you just show it like this, employee class. It's a very nice representation. The nice thing is that this representation is shared by all of the object-oriented programming languages, including Java or C# or whatever object-oriented programming language you have, okay? So in fact, there are some tools which are called computer-aided case tools. Computer-aided software engineering tools, case tools, okay? There are some case tools that will take this figure, okay? You just do this, okay? You just draw this shape, and by looking at this shape, it can produce C++ code or Java code or C# code, whatever you prefer, okay? You just give this figure, you just define this UML diagram, okay? These are called UML, Unified Modeling Language, okay? UML. You define these UML class diagrams, and after you define them, producing the code is done by the case tools. It's automatic. What happened? Where did it go? Where is my... Here it is. Okay. Unified modeling language is a representation way. So this is, in fact, this is what we are going to do with the... Why is this happening? Okay. This is what... Maybe I should save it. Oh, I think I am out of... I am both out of time and out of battery. It looks like... no, I am not going to let you go because we started late. Who is going to come after? There is a class right after this. What? Are you talking in Turkish? Okay. Since I did not understand what you said, I can continue. My cheap Chinese power adapter. Wow. Do this first. Get the static out. Worked? Kind of. Okay. I am going to hurt this computer, but well, it's going to die anyway. Kind of works. Okay. So this is what we are going to do. We are going to, no, it is not that. Let me get rid of this. Discard changes, all of them. Close all document. Oh, no, don't. Okay. Turn it on. Am I charging? Yeah, I am charging, right? Yeah. Okay. Inheritance. Okay, this is what we are going to do. This is, okay, UML diagram. We are going to say that this is our employee class. And we are going to do this notation. Again, a UML diagram. This is my salaried employee. Salaried employee. Okay. This salaried employee is exactly same as employee class, only it has, okay, set salary and get salary as functions, and it has a private salary double. Otherwise, it is exactly the same as employee class. And in fact, there is an is-a relationship between them. Is a relationship. Salaried employee class is an employee class. So what does that mean? It means that whatever employee has, salaried employee has it too. Okay? So employee has get name, set name, right? Salaried employee has it too. Employee has set social security, get social security. Salaried employee has the same thing too. Okay? And the compiler knows about it. The language knows about it. And the way you tell your compiler is this one. Let me open salaried employee. Okay. See how it is done. We just say, okay. Salaried employee is actually an employee. Okay, line 14 is something that we are just seeing now.
I would say public.
Ignore this public thing. We are going to see it later. Okay. Salaried employee is actually an employee. On top of it, I am going to put the salary in it, get salary, present salary, and of course we will have our constructors. And if you look at the implementation of salaried employee, this is the whole implementation. In the implementation, I just provide this get salary and set salary. Print check didn't work the way I wanted. I am redefining it. And of course, I am going to write my constructor too. So the whole salaried employee thing became, remember, this was a large file which repeated all of the functions of the employee stuff. Now I don't have to do that because the compiler knows that get name, set name, get SSN, set SSN, etc. They are all available and they are all valid for this salaried employee class. This is called inheritance, kalıtım, miras, okay, in Turkish. So salaried employee inherits everything from employee, okay. Whatever employee has, salaried employee has it. But on top of it, it gives more features, okay, more specific features. Salaried employee class is an employee class plus some more features, okay. Another example, good example for software reuse, and this is called inheritance. All of the object-oriented programming languages support this, and it's again one of the basic principles of object-oriented programming languages, and one of the main tools of software reuse in object-oriented programming languages, along with composition. Okay. So tomorrow morning we are going to continue from this point on. I'm going to stop at this point now. Okay.